So this is my solution. Oh, I'm sorry. I'm gonna.
Camera?
Bottom.
Yeah.
Okay, so I have 28 and then 21.5. And now I want to talk about something you probably forgot to mention. There's something called physical domain. Physical domain is very, 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 very important, especially if you are engineering. Why? Um, I know I repeat the same story over again because kind of very important story for me is there's two parts of the story. One part is never underestimate somebody. So I was teaching a group of kids, right? In the summer, it's like summer camp. It's like math camp, and I was teaching those group of kids. And those group of kids, they have parents, and the parents decide to sit in one of the lectures. So I was teaching those seventh, eighth grader how to do calculus, and we're doing related rate. We finished with related rate. We talked about optimization. And there was one parent, and remember, one guy asked me, "Is like, Mr. Ye, do you mind if I can go over something? I think you're missing something on the calculus part." I was like, "Who the hell are you?" But anyway, I'm glad I did not do that because I always learn to like never underestimate somebody. So I was like, "Yeah, sure, why not?" And so he went up there, he introduced himself, and he's like, "Okay, yeah, my name is Dr. Wang. I'm at UCF. I'm a civic engineer professor." I was like, "Well, who the hell I am?" So, um, he's a Dr. Wang as opposed to Mr. Ye, right? So we went up there. He was talking about something. He says like, I was explaining this question, and he says, something you forgot to mention is something called physical domain.
And that's just meaning like you can't have something be a negative size, right?
Yeah.
Or like the hole can't be like 1,000 inches long.
Yeah. So the thing about it is that physical domain is actually very important because physical domain, because you're engineering, you're not gonna have unlimited material. You only have maybe a sheet of paper. You have to build an airplane. That's fine. That's your physical domain. So you have to understand that the most thing that you can cut, you cannot cut more than you cannot cut more than 10.75 because remember if you cut more than half of here you don't have anything to form your rectangular, right? I think somebody Omar in the first period says, "Oh yeah, can I cut like 20 inches?" I said, "No, you cannot cut 20 inches. You have no boxes left if you cut 20 inches." Now this also happened in chemistry as well. In chemistry, we have a different name. Instead of physical domain, in chemistry, called a limited reagent.
I remember that, yeah.
Limited reagent is just the amount of material that you can consume to have the whole chemical reaction. There is the other side is going to be excess. It's going to have too much. You don't need that much to form this thing. So I was a chemistry major. I know that limited reagent is just like a physical domain. Okay. So first thing first, I multiply those three lengths together, which is 28 minus 2x, 21.5 times minus 2x, and times x. Why? Because if I fold it upwards like this, right? If I fold it upwards like this is going to be x. And this is going to be 28 minus 2x. Why? Because I folded, subtract 2x on both sides. And this is 21.5 minus 2x. And that's how I establish this value. Now, I go ahead and multiply everything together, and I take a derivative. Why derivative? Because derivative help you find a maximum. I can take a derivative, plug in 0 for the derivative, and I solve it use quadratic formula. I got 4.02. Which is most of you guys got 4.02. I think that's what Avidash, Ethan, Avidash, you got 4.02? Yeah, good. Right? And I think a lot of people physically try until they get 4. And that's fine. But this is the idea. At first, that you guys realize that if you cannot cut as small as you can, because some people decide to get cut like 0.1 centimeter, and just doesn't work because you can fold it upward. It's gonna be very flat box. the volume is actually very small compared to the very tall box. Okay, so the idea is just like what Ethan said on the discussion is he was saying it's like at one point it's gonna be it's gonna keep on going up like a parabola shape, and then at one point to a certain maximum it's not gonna be diminishing. That's exactly what he says. Okay, so that's very, very important. Now if I would do this and if I to graph this, so I'm gonna graph this, I'm gonna graph on this. So those are the things that you should learn how to use calculator and also understand your physical domain and understand your physical ranges is. Now, if I were to graph that, so I want you to use a calculator and graph this function. So it's x times 21.5 minus 2x times 28 minus 2x, and I'm just doing v of x there. And if you graph it, you can come up a straight line, and you say, well, what is it supposed to be able to tell me? It doesn't tell me anything here because it only can see certain part of the graph. You have to change that graph to favor of you. How do I do that? Okay, try it. Get a calculator out. Type in this equation. How do I see the whole graph using computer? Because later on, you're going to translate this knowledge to your graphing calculator. You got to learn how to change your window on your calculator. If you learn how to use decimals now, if you lay down changing to calculator, it's very easy. Just one button window or menu windows. Once you go to window, but in decimal it's very easy. If you go to click on the right hand corner on the top, it says a wrench right there. You click on the wrench. Okay. And then the x-axis, you see that minus 10 and positive 10 there for x-axis? That's going to tell you how your microscope is zooming in on which part. Now, I don't like negative 10. The reason why is I cannot cut negative x here. But I do like negative 1 because I want to see a little bit of y-axis to see what happened here. I like 10, but I would say I want to see the whole graph. So I'm going to go all the way to 15 because 10.75 should be the maximum. So I'm going to do 10. I'm going to do 15, just like that. Now I see 3 lines. When I see 3 lines, you say, okay, well, what am I supposed to see? You got to see the value. The value you accumulate from last week is all like 600, 700, 800, 900, 1,000, right? And this is, so it's 1,000. Madison, pay attention. So if it's 1,000, I'm going to go with negative 1 to 15. And I'm going to go to, I say negative 10 is fine, but it's going to 1,000. And if I go to 1,000, I almost see the whole graph. Now, if I zoom out a little bit, I see the whole thing. Now, that was a graph instead of 3 straight lines. Because 3 straight lines cannot tell you anything. This graph can tell you a lot of things here. Pay attention to this graph. You click on any moment of this graph. Some of you guys try cut 1. If you cut 1, your volume should get roughly around 511. Do you remember that volume? If you cut 1 centimeter. If you cut 2 centimeter, it's going to give you what? 840. 3 centimeter is going to be what? But all the way up is going to be 4 centimeter. 4.02 is going to be your maximum. After that, so after this point here, there's already no more box. You're going to say, oh no, there's another maximum over there later. But there's no more box. There's imaginary box. Right? So 10.75 is your restriction. Now, I want you comparison to this graph. Let's look at the v of x graph. Look at the original graph here. This is v prime of x graph. Where's the maximum occur? On original function.
At 4.22 because it's where it's 0.
It went from positive to negative, right? And look at here, 12.48 went from negative to positive. It's relative minimum, even though that's outside the physical domain. But as far as the math domain, you still can see relative min. You can also see that this positive is increasing all the way to 4.02. After 4.02 is decreasing. After 12.48 is going to be increasing. Do you see concavity? Where do you see concavity? Slope is what? Negative or positive? So where's negative? 8.25 is gonna be what? It's concave down, and at point 8.25 is gonna concave up. Look at original function, how accurate that is. Look at this. 4.02 is the maximum. 12.48 is the minimum. And it's increasing, decreasing, increasing. Do you see that? How accurate this is. Look at 8.5. That's where the inflection point. 8.5. Roughly at this point here, right here, right? 8.25, sorry. 8.25 here. It's a roughly inflection point right here. You can see before that it's concave down. After that it's concave up. So this is truly understanding how graph works. And you can see that in the original function. Original function is the volume of the box. Look at second derivative graph. It's below x-axis. That means at v double prime of x is negative. It's concave down. Also shows the exact same thing. At 8.25, before 8.25 is negative. It's concave down. At 8.25 is positive. It's concave up. It tells you all the information, 3 separate graphs. We're not teaching only optimization. We also teach you how to analyzing the graph. Now, yeah. With that being said, there you go. That's optimization. Take a derivative, set it equal to 0. Find out the critical number and make sure they are maximum and minimum. You maximize something, you minimize something. That's your optimization. Now we're gonna go to the next question. I cannot find a box, but usually there is a box. For example, that I'm gonna go to this questions here. I'm gonna let you read this question because this question is gonna be your first part of the homework. We're gonna look at question 11. You might want to write down the question 11. There's not a lot of words. Question 11 it says open top box. What does that mean? Right?
Box with no lid.
Box with no lid. Good. Now I have this box here. I have a lid. But do you want to have no lid on the top? Okay. Actually, that's more like a Celsius box. This box here. This box here at the bottom looks like a square base. So it looks like something like this. Okay. And at surface area 108, that means everything around here, lateral and the base on the bottom. Not the top, there's no top.
Does it include the inside?
No, it inside, what do you mean? The volume?
Yeah, I didn't. No, I didn't know if the surface area included.
No, not including the inside, just only the outside. So now you see this box. The bottom is a square. It's a square. I think it's a square. Does it look like a square? I don't know. I cannot tell. It looks like a square, right? Okay, so it's square and the 4 sides. Now, they also have to tell you surface area is this much. And you say, okay, well, I'm gonna do this problem. And I'm gonna do this problem where it makes sense. So I'm gonna show you how to do it. So I'm gonna do it here. So I have a square box. By the way, you guys need to know how to draw a box. There's no lid, only in the bottom. So the first thing is this is square box. This is square base. I'm sorry. And we want to maximize the volume. Maximize the volume. And there is a surface area. All right. Okay, so there are three things I need to know about this box.
I have my eraser back.
Okay. So you want to maximize the volume and the square base. What does the keyword square base mean?
Base to the second power.
Huh?
Base to the second power.
No. What?
The length and width are the same.
The length and width are the same. So, and the one thing that you have to be able to do on data rate and then an optimization is to create the assigned values. So I'm gonna assign this to X and this to X. Is that okay? Hi.
I need a signature.
For I'll sign, but I don't know what am I signing for.
Based on the entry from last year, then if I need name and you choose the number.
Okay. 108. Now this is H. Why do I assign H? Because they're different length, right? So what is my volume in terms of this variable?
Volume is x squared h.
X squared H, good. But the problem is, if I take a derivative at this moment, what happened?
You get an implicit derivative.
You get implicit derivative because you got X and H, right? So we're gonna call this is a primary equation. Primary equation is the one that you take a derivative. But usually, it's not enough for you to take a derivative. So, I'm going to say b equal to x squared h. And I'm going to say, okay, well, we also haven't used the surface area yet. So, surface area is equal to 108. What is 108 is equal to?
4xh plus x squared.
Does anybody have different opinion? I think some people have different opinion. Well, it turned out their opinion is right. Because you think about it, this x times x, right? This is the base. This is the base. This is the square base, so it's x times x. But there is 4 times x times h. Right? This is the x, this is the x, this is the x, this is the x, this is the h. The height. Because there are 4 different sides. So it'll be x squared plus 4xh. Is there any questions so far?
Oh no, it's not.
Okay, so then you're gonna say, well, why do we need a secondary? Or they also call it constraint. constraint. How to spell constraint?
R
Or A-N-T?
A-I-N-T.
A-I-N-T. So constraint, or we call it secondary equation. So constraint is because I only have that much material. I only have 108 as a surface area. So that's a constraint in terms of like kind of like physical restrictions, right? Because that's among the material I can have. But with that being said, that's nice because if I have this constraint, I can solve for a variable. Because the goal is like just like the cone problem on your related rate test, you can reduce a variable due to your similar triangle. Here you can reduce a variable due to your constraint. Is everybody following me so far? Yeah. So same situation. So it'll be 108. I'm gonna solve for h. So I'm gonna circle this h. So I'm gonna minus x squared equal to 4xh. I'm gonna solve for h. H equal to 108 minus x squared over 4x. And what happened is I'm gonna do volume is equal to that. X squared times, and this is gonna be 108 minus x squared over 4x. You have to be able to come up with this. Now I'm just gonna simplify as much as I can and take a derivative. I'm gonna simplify this, so it'll be, I'm gonna cancel this x and x, so it'll be x times 108 minus x squared all over 4. So volume is equal to 108x over 4 minus x cubed over 4. I'm gonna simplify this because 27x minus x cubed over 4. Now I'm gonna take a derivative. That's 27 minus 3x squared over 4. I'll set the equation equal to 0. I get 27 equal to 3x squared over 4. Multiply both sides by 4 is 108. X squared is equal to 27. No, 36, sorry. X is equal to 6. Now remember, 108 equal to x squared plus 4xh. If the x equal to 6, that means 36 plus 4 times 6 times h. So it'll be 72 equal to 24h. H is equal to 3. If you got x equal to 6, so it'll be 663. So it'll be 6 times 6 times 3. That is the box dimension to create a maximize. How do we know we maximize it? How do we know we maximize this? Well, the thing is, I can take a second derivative. If I take a second derivative here, I'm going to get 0 minus 3 over 2x. So if I plug in 6, negative 3 over 2 times 6, that's equal to negative 9. It's negative 9 is concave down. It's concave down, that critical value has to be a maximum. So this proof is a maximum. And we just solve a difficult problem. How much time we have? 12 more minutes? Sure. Let me know if you have any question before I go in further.
Could you zoom back down here?
Which part?
No, it's fine.
Okay. Any questions before I go on? So I want you to try one questions. The question I want you to try on your homework is gonna be this one. And here's what I would do. If I were you, I'm gonna do. Suppose you have 102 fence makes two side by side enclosure and show. What is the maximum area that you can have? Now 102 fence here is the material you have for fence. So it's not perimeter, it's all the things that around even the middle section. Now, for what I would tell you to do is I will assign variable, and I would assign this way. This is what I would do is assign. I will assign this is y, this is y, this is y, and this is x, and this is x, this is x, and this is x. Now you want to maximize the area, so try yourself. See if you can do number 5. Remember, constraint is to help you reduce one variable. So sleepy. I'll tell you the answer. If you did it right, you will get total 433.5 square meter. That's the area. You guys got it? What time we get out of here? 5 minutes? Mm-hmm.
Meters squared. Yeah, just look at all of them. Well, now you even have to have one of those with you. The little range of stickers.
I do, yeah.
Wait, did I get any?
No, it's just a little button sticker.
Whole room. Get any little. I think you have this part off. X. That's supposed to be 4x plus 3y. Or 3y. Wait, is it supposed to be the surface area or the perimeter? Like the amount of fencing?
The amount of fencing is just it's 3x.
Did you guys get 433.5?
Yeah, that's
There you go. Thank you. Glad I gave you that.
These stickers.
Name with sticker.
I don't think I have it.
Okay.
That's like
So area is equal to what?
2xy. 2, yeah, 2.
Good. And what is 102 is equal to?
4x plus 3y.
Okay, so did you
You mean 108?
108 or 102?
102.
That's 102. Sorry.
Why did I do 1?
Oh, I did 108 because the other one was 108.
Yeah.
Oh, so all of this is wrong. Well, maybe not.
That would be small.
I don't know why I'm doing Y, but okay. So it'll be 51 Y minus minus 3 over 2 y squared. A prime is equal to 51 minus 3 y. Y is equal to 17, I think. Is that right? And then plug is 17 in here. 102 minus 51 over 4. And that's equal to 51 over 4. I have no idea what is that. 25.25? No. 12.75? So it'd be 12.75 times by 17 times 2. I don't know what is that.
430. Equal 8 meters. What is it equal? 12.75.
Oh, you know it earlier.
You split that? Yeah.
You're right.
Use Instagram, right?
I need coffee.
Did you have long already? Oh. Wait, why don't you know already?
I think, yeah, I need to think too.
I'll come to Montreal. No, like I have something to do. I'll come tomorrow.
Uh-huh.
I promise. I promise. I'll come. If I say I promise, I'll come.